I never thought a laboratory would have a swimming pool.
Me either. I wonder what they do here.
I'm glad you asked. You two must be the treehouse detectives.
Yes, we are.
Well, my name is Mr. Utley, and this is the Neutral Buoyancy Laboratory, or NBL. We use this tank to simulate a weightless environment just like you'd see in space.
It sure is big. Just how big is it?
The NBL is 202 feet long, it's 102 feet wide, and 40 feet deep. That means it holds just over 6.2 million gallons of water. That's as big as 12 Olympic-sized swimming pools all put together.
Wow, that is big. Why do you need such a big tank? I mean, laboratory.
Well, the International Space Station components are really big, so we need to have an environment that was big enough to be able to have astronauts practice putting all the components together.
How do the astronauts train in the NBL?
Well, instructors coach the astronauts on tasks and techniques in spacewalks that they're going to have to do while living and working in orbit.
Spacewalks? Why would they need to walk in space?
Well, sometimes astronauts have to go outside of their space home to do such things as assemble the space station or even fix the Hubble Space Telescope.
Is there anything else they do in the NBL?
But yes, as a part of spacewalk training, they train on tasks like connecting power supplies, deploying radiators, deploying solar arrays, or even changing batteries.
Changing batteries? That doesn't sound very hard.
Why do you have to train for such easy jobs?
It may sound easy, but working in space is very challenging. There is no up or down, and so objects may not be in the same orientation they were in when they were training here in the NBL.
At least all the heavy stuff doesn't weigh as much as it does on Earth.
Well, actually, even though it's weightless in orbit, objects still have their mass. So you have to be very careful about moving a large object quickly because it will build up momentum. So astronauts have to train to be able to move things very slowly and deliberately.
This is a lot more complex than we thought.
Why do you use water?
We create a weightless environment by using the principle of neutral buoyancy.
What is neutral buoyancy?
Well, neutral buoyancy is when an object has the same tendency to float as it does to sink. And that just hovers in the water. And that is the same property as being weightless on orbit. So you can take a 190-pound astronaut, put them into a 200-pound spacesuit, pressurize the suit, and then add weights to the chest, back, and arms and legs just so that they're hovering around in the water. And that gives them the same reactive forces that they would have in orbit. So when you push yourself away from something, your body is going to continue to float away from it.
If the suit weighs 200 pounds, how do you get him out of the pool?
Actually, we're taking the astronauts out of the water right now.
Wow, those suits are awesome.
If you really want to know more about spacesuits, you should talk to Dr. Ross here at Johnson Space Center.
That would be great.
I'll give her a call and let her know you're coming.
Thanks, Mr. Utley.
Bye.
Bye.